Okay, so Tech Talks are a set of conversations we're having here at Mondial Police University that are open to our students with the presence of industry experts from all around the world. We think of them as a playground for experimentation, so our students can ignite that learning and that passion with technology. So we think that conversations like these, although they might tend to be technical, can offer better mileage for our students in terms of learning, shaping their passion, and to offer them a very strong early career guidance. So today we're joined by our guest, Mr. Abdel Srewa. Abdel is a senior cloud engineer at Google with a focus on serverless solutions, Kubernetes, and also DevOps methodologies. I came to know him through his very interesting podcast, a very insightful one, where he talks about career development and cloud careers. Okay, please welcome Abdel. So we have today with us Abdel. Abdel, how are you doing?
Hi, I'm good, thanks.
Can you hear me?
Yeah, I can hear you.
Okay. So I will start with some generic questions, and after that I'm joined with my students from the fourth year of computer science. We have a general program, and they would like to ask a few questions ranging from technical aspects to career development and career guidance. Okay?
Sure.
Okay. So first of all, who is Abdel, and what is the story behind what you're doing? I mean, the job at Google, the career guidance, the tech advising, and everything around it.
Yeah, sure. So Abdel is my nickname for non-Arabic speakers because my long Arabic name is sometimes very hard to for like non-Arabic speakers to spell. So I go by Abdel, but Abdel is my real name. So I work at Google right now. I'm gonna start in the chronological order. So I got my high school degree, so baccalaureate in 2011, I guess. Then after that, I've been to two different schools, which we know in Morocco as Listia or Low PPT. It's like professional education. I did like two different degrees, two different fields. One was telecommunication and electronics. The second one was programming. Then after that, I've been to do my master's degrees in a private school, Ligia or LISDGI is called now. I did 3 years of master's to get my software engineering master's, also like a generic degree. After that, I started working in Morocco. I started in a company called N+1. It's a data center. It was the first data center to open in the country. So it was the first, we call that ISP neutral data center, which means basically that we had a building, which is data center, and then we had fiber coming from all the ISPs. And when customers host stuff with us, so when they bring their own servers, we don't force them to choose one specific ISP. They can come, they put a bunch of servers, some switches, and then we can connect them to, to Salat, Maghreb Telecom, Inwi, or Meditel at the time. So I worked there for 2 years and a half. What I was doing at the time is what you could call today DevOps, which is a little bit of programming, a little bit of system administration, a little bit of architecting databases and stuff like that. But because it's a startup, so I was pretty much doing everything, right? 2 years and a half in, I was contacted by Google, who asked me to apply for their data center in Belgium. It's one of the largest data centers we have in Europe. So I joined as a hardware operations engineer, it's called, basically working on the hardware side of data centers, so that's servers and switches and network equipments. So I did about 4 years there, ranging from working in the data center itself to working all over Europe, Middle East, and Africa on, when you pull up your phone and you are trying to watch a YouTube video, we don't stream that YouTube video to you from a data center because otherwise you're going to get a poor quality because of the network latency. So we stream it from what we call a CDN, a content delivery network, which is essentially a bunch of servers we just deploy all over the world. And we have them all over the place, right? It's like sites which are owned by us. There are racks inside, there are servers. And so I was part of a team that just maintains this infrastructure, so deploy it, upgrade it, etc. So I kind of traveled all over the place. And yeah, 4 years later, I wanted to do something else. So there was a role opened in the Nordics for a cloud engineer. So I came here in 2017. I joined something called professional services. This is where I work right now. So professional services is the kind of consulting branch of Google Cloud. So Google Cloud is like a big org where you have the people selling stuff, you have the people building stuff, and then you have the people helping the customer to implement stuff, and that's us. And so within this organization, we have several roles. My role is a cloud engineer, and that's kind of like the most technical role because we are focused on certain technologies. You talked about it earlier, so Kubernetes, serverless, service mesh, infrastructure. My background is in infrastructure, so I'm like a network and system administrator dude. And yeah, that's basically my background. I've been here now for 4 years in Sweden, and yeah, 4 years in cloud. Cloud as Google is pretty new, so there's new stuff every day, and we're still like having fun learning things.
Great. Okay, thanks for that. I think that's a very interesting track. You started like doing everything in a startup. Later on, you specialized in hardware, and now you're working on the solutions. So you know the architecture of cloud computing from back to back. I mean, I'm not going to ask very specific questions right now. I'm going to step back, and I think my students have prepared a set of questions for you. I still have hope that the questions might not get too technical, but I doubt, because whenever you gather a group of engineers, the students or senior engineers, I mean, they end up creating problems, trying to solve a bunch of problems. Okay, so the first questions or set of questions will be by Aya. Present yourself and start asking questions to Mr. Abdel.
Okay, hello everyone first. Hello, Mr.
Can you, Abdel, can you hear?
It's far away. I cannot hear.
Okay.
Can you talk a little bit more loud?
صح؟ نطلقه ما تقدر
Okay, can you hear me right now?
A little bit louder.
D'accord. So here is Aya. Here is Aya. Aya is Aya is a student in fourth year in computer science. I mean, she is right now working on several projects in web development, gamification for a certain startup. And yes, she deals with cloud solutions, and she uses them for like every day in her training. Here you go, Aya.
Well,
Hi.
hello, Mr. Abdel. Hello.
Hi.
It was great to know you.
Thank you.
You are already famous.
Thank you.
Well, I have some questions to ask you. Well, first of all, what are the advantages of using cloud computing, especially the security aspects provided with the cloud?
Sure. So the advantages of using, I mean, I have to start with saying something. I am naturally biased because I work as a cloud provider, right? So of course, for me, if you come and say like, hey, should I use a cloud provider? I would say like, yes, you should do that. And if you ask me which cloud provider I should use, I would just say like, hey, Google is the best, right? But just trying to be unbiased in my approach to this question. I'll start by saying something very simple. I'm a strong believer that if you have a business and your business is not in IT, so your business is to make burgers, you should not be focusing on doing IT. You should not be doing IT on-prem, period, right? You should not be having your own servers and hiring your own people to do that. Maybe you need developers to build your website, your web application, etc., but you shouldn't. It's not in your core business to handle servers or infrastructure. So, so the advantages essentially of using a cloud environment is that you get somebody else to take care of the boring stuff you don't want to do, or the stuff that doesn't bring a lot of value to your business, right? So if your business is actually making burgers, you can focus your resources and investment on making burgers and making them better and selling more burgers instead of investing money on buying servers and switches and routers and stuff like that. There is something you have to understand. fundamentally, from an infrastructure perspective, hardware has a duration of life, right? When you buy infrastructure, when you buy servers and switches and hard drives and stuff like that, it's not a one-time purchase. You don't just buy it and then install it and forget about it. It's something you have to constantly do. And that's where typically when we talk about running your own IT versus buying into cloud, we talk about this concept of TCO, the total cost of ownership, or the operational cost, so CapEx and OpEx. So CapEx is essentially the amount of money you have to put upfront to buy the hardware, to buy the software you need to run your IT. OpEx is the amount of money you have to put to actually run that IT. So that goes into electricity costs, internet costs, salaries for your employees, etc. Basically, what you are aiming to do, if your core business is not IT, so if you're making burgers, again, going back to the same example, you want to minimize your CapEx and make your OpEx predictable. If you do your own stuff, if you do your own software and your own hardware, you're going to spend a lot of amount on CapEx because you have to acquire everything at the beginning. And then you're going to spend OpEx on it over time, but your CapEx expenses will come up every couple of years. So every 5 years, you will have to replace your servers, you will have to replace hard drives, you have to buy new switches. Every 10 years, your provider will say, okay, well, that model of a router does not support it anymore, so you have to buy a new one, etc., right? So by using cloud, you're essentially going from this mode of I need to acquire hardware to I just click a button and I get whatever I need, and I only pay for it whenever I need it. And that's actually a key differentiator when it comes into using the cloud's resources, is that they are typically pay as you go. So you only pay for the amount of resources you use. To give you an example, and I'm just going to use Google as an example here, if you create a virtual machine in Google environment, you only pay per minute. So if you use it for 62 minutes, you only pay 62 minutes. You don't pay 2 hours, right? If you use it for the whole month, you get something called a sustained use discount. So you get like a 30% off the cost of using that virtual machine for an entire month. That's not going to be possible with on-prem, because if you do this on-prem, you need to buy a server, you need to buy a software to have your virtual machine up and running. And then when you are not using your machine, it's still there. It's still costing you money because it's consuming electricity, and there are people hired to take care of it. So it's costing you operational costs. So these are like the key difference, right? When it comes into security, I think it's pretty clear through the years and through history that big cloud providers usually have better security than anybody else. That's very simple, because when you are a small company with a small team doing your IT stuff, you cannot afford hiring all the experts you need, right? So you will see this, like this is something that you will notice when you go out to the job market as students now, is that if you go to a company that just do their own IT, like a bank, for example, right? And if you just look at their expenses on terms of IT, you will see that a huge part of that goes into security stuff. So they have to buy antiviruses, they have to buy firewalls, they have to buy VPN appliances, they have to buy a bunch of stuff they need to be able to be safe, right? So essentially, you are not actually controlling your own security. You're just depending on somebody else to provide you with security, because you're buying solutions that already exist in the market. And in the last couple of years, I'm not a security expert, but I'm following kind of the trends of what's happening. In the last couple of years, it has been proven that one very successful vector of attack from a security perspective is to attack the people selling security software. And so there was this example lately in the US, I forgot the name. It's a pretty popular piece of software that everybody uses, and then somebody hacked them. So they hacked the software, and obviously when people upgraded the software in their own infrastructure, they got that vulnerability. They pulled that vulnerability down, right? So when you go with cloud providers, we can afford investing in putting people and resources and stuff in place. We can afford, we have the money and we have the resources to afford hiring the people, the best of the best, to be able to run a secure environment. So that's my take on that, I would say.
Thank you, Mr. Al-Fatah, for your answer. We're gonna pass to my second question. Mm-hmm. It is, how can small businesses benefit from implementing the cloud within its solutions, like products, services, and which cloud model is best for such small businesses or startups?
Yes. Abdel, before answering this question, because we have industrial engineering students following the episode, Is there a way to convince small business owners and SMEs, small to medium enterprises, to go for the cloud? I mean, we as consultants and professors, we deal with these companies, and it's hard for us to convince them to make the shift. I mean, we know that there are cost benefits, we know there are security benefits, the integrity of data, the long-term support, and all the benefits, but it's hard for us to convince those solutions, those companies to go for the change.
Yeah, I can give you a very simple way of trying to. I'm not a big fan of this idea of trying to change people's mind. I think that the best way to try to convince people to adopt something is to get them to come to the conclusion of why they should do it. So you should let them come to the conclusion by themselves. It's very simple. Take any small or medium business, right? And ask them what is the key piece of software that if it's down, you are losing money. 95% of the cases, they're going to say email. If my email is down, I am screwed. I cannot talk with my customers, I cannot talk with my partners, I cannot do anything, right? And then the next question is, can you run your email servers on-prem and ensure it's up 100% of the time? And 90% of the cases it's going to be no, we can't. Or just ask them in the last month how many times you couldn't access your email because your email servers on-prem were down, or because you forgot to pay your internet connectivity, or because your electricity was out, or because somebody made a mistake, somebody was having a terrible day and then clicked the wrong button and then just broke everything, right? So it's basically a matter of explaining to people that if your core business is not IT again, you want to use something that exists so you don't have to spend time and money managing it, right? And then when you start having this conversation with people, then the concept of cost come in, right? So somebody will go, okay, well, I'm running my own email server in my data center. It costs me, I don't know, $1,000 per month. Just throw in a rough number here, right? Like $1,000 per month. That's electricity, internet, the people managing it, etc., etc. Just a random number. I'm not saying that people should be paid $1,000 per month, by the way. I'm just giving a number here. And they go like, oh, but we can actually put, I don't know, 200 mailboxes on that, right? So if we try to replace that with a managed mail solution like Microsoft 365 or Google G Suite, which we call now Workspace, then each mailbox is going to cost me on average $10. So for $1,000 that I'm spending on my server on premise, I am only going to get 100 mailboxes with Google or with Microsoft, right? While I can do 200 mailboxes with my on-premise server. So the cost conversations comes into place. The way to approach that is essentially, if you want to take your infrastructure as it is today and bring it to a level where you can ensure the same level of availability that a cloud mail solution can give you, right? What would that cost be? Because if you're running on a single server, all your mail stuff, and that server is down, you have downtime, right? Now, what I want you to do is I want you to take this infrastructure and change it such a way that it gives you a higher availability, right? So the natural answer to that is going to be, well, I'm going to need another site. I have to run 2 servers or probably 4. I have to have 2 redundant internet connectivity. I have to have 2 redundant power connectivities. I have to have replication between the 2 sites, right? I have to have a way to do failover. So if my active site goes down, I have to go to the passive one, etc., etc. And then once you start going into this space, your costs will start increasing like linearly. I think that a lot of times people who are into this, who are sitting on table to make decisions about how to buy cloud solutions, they always try to think about cost first. They don't think about benefits. And I find it very interesting, which I have done in the past, to sit down and start talking to people about benefits. And benefits of having higher availability, benefits of potentially cutting your costs by going to a cloud solution, benefits of not having to spend time managing something you're not supposed to be managing because that's not your core business, right? And then for small businesses, obviously, because I was in a startup, although the startup I was in, our core business was IT. So our core business was selling IT to other people. Yeah, by the way, this is a true story. Even when I was working at that company in Morocco and our core business was to sell IT solutions to other customers, we did not host our own mail server. And a lot of people make fun of us because they were like, well, you're a data center and then your email is with Google, right? Because you can easily see that. You can just query the domain and then you see the MX records in the domain and then you see, okay, these are Google MX records. So this is a Google workspace account. And then you're like, yeah, that's true. But if my data center is down, I still want to be reachable by my customers, right? So that's why we didn't host our own mail solution. So for a small company, there are certain things like if you're a single person company, like you're a founder, you're just starting to launch your thing. Like, do you really want to spend time building your websites, building your infrastructure, putting things on the infrastructure, upgrading, patching? I mean, it's fun, yes, if you are in IT, but it's not what you're supposed to be doing. What you're supposed to be doing is actually spending time trying to sell your thing, right? So obviously, I mean, I can give some examples of companies that started as small companies. Now they are like big ones that just went for cloud and that were successful. A very popular example would be Snapchat. When Snapchat started, they had 10 engineers in total. And what they decided to do is we're not going to buy servers and configure them. We're just going to go for App Engine, which is a platform as a service solution from Google. They built the entire Snapchat on top of App Engine with 10 people, and they managed to get it from, I don't know, 10 million users to 100 million users within a few months. They wouldn't be able to do that if they were on-premise. Another example would be Spotify, which in 2018, they have decided we're going to get out of our on-premise data centers and moving everything to Google Cloud. And the reason why they did that is because they started hitting some capacity limits in their own data centers. And there is no better example, I think, that what's happening right now. Like right now, we're in a pandemic. We finally realized it was something that everybody knew, but we realized it now that, oh, a lot of things that people need are only manufactured in a single place in the world, right? Servers are mostly manufactured in China or in Asia in general. And when China is down, well, no one can get servers. So if you are a startup and you need to scale out and you have your own stuff on premise, well, good luck finding servers. Good luck finding hard drives. There was a hard drive shortage like 6 or 7 years ago because of something was happening in Hong Kong. And then no one globally could, like even Google couldn't get hard drives, which was horrible. So imagine you are a small company, you are a Spotify type company 6 years ago, just starting, you suddenly became popular, you have a lot of traffic, you have a lot of users. And then, well, you cannot store music that you can stream to people because you cannot get enough hard drives to store to put in your own data center, right? And that's the kind of things that cloud give you. It's what we usually refer to as elasticity. Is basically being able to scale up and down quickly without having to care about where those resources come from.
Okay, thank you very much. Thank you very much. So, if I got this right, it's more about elasticity, scalability, high performance, high availability to your customers. Exactly. Or if IT is not your core business. Is there any? Let's talk about the other side because the list is huge about the advantages of cloud computing. In which particular case you'd recommend to stay on-prem?
Yeah, a very good question. The most obvious one would be if you want to go to cloud, but there is no cloud provider in the geographical region where you live. Like if you take example in Morocco right now, in Morocco there is no Google, IBM, Oracle, Microsoft, Amazon, they don't have any data centers there, right? And if you are trying to build a solution which handles Moroccan citizen data, you cannot put it outside of Morocco, right? So in this case, you don't have a choice. So just think about the ongoing programs about the, I'm going to say it in French, the Sécurité sociale pour tous, la sécurité sociale générale, right? The CNSS for everyone, right? So that means that the CNSS and all these kind of organizations in Morocco, they have to handle citizen data. They have to store your identity card, name, email, which we usually, these are the things that we refer to as PII, private identifiable information. In Morocco, there is a law that says you cannot store this outside of the Moroccan territory. So, and if you want to use a cloud provider today, you don't have a choice because there is none. I'm talking about the big ones, right? I'm talking about the small hosting companies which pretend to be cloud providers, but they're not. I'm talking about the big major 5 or 6 big companies, right? This is one case. The second case would be latency. If your application is latency sensitive, like a video chat application is typically latency sensitive, you might not be able to store this or run your service far away from the user. And when I say far away, I'm not talking about physical distance. I'm talking about network distance, right? Like how many hops do you have to go through in order to reach the service as a client? A third one could be regulation. I don't know if you know this, but the European Union is now trying to actually build their own cloud. Well, good luck doing that, but they're trying to do it because they don't want to have dependency on the big cloud companies because they are all Americans and politics kind of play a role in the relationship between Europe and the USA. So that could be a reason. That could be a reason why you might want to run your own thing because you want control over your data. You don't want, I mean, although to be very clear, when I'm saying control over my data, I mean having access to it whenever you want quickly and being able to take it down whenever you need. Cloud providers do offer that, but there is still a misconception about the fact that when you store your data in a cloud provider, you don't have control over it, although you do. But like, you know, people don't really understand what that means. But the point here is if you have some regulations that could prevent you from using one of the big cloud providers, you might want to stay on premise. And it could be cost, right? Sometimes running your own infrastructure, even with the highest availability possible, is going to just cost you less. Yeah, these are probably the use cases that I would think about. Maybe another one, which is what I'm doing right now is basically working with customers that are kind of, most of them are legacy customers, we call them, so banks and financial institutions and stuff like that. And they are in this transition phase where they are going from on-premise to cloud. And it's actually a long process. It takes a couple of years. And they are going to stay on-premise for a simple reason that they have already invested money in hardware, right? They don't want that investment to just be gone. So they have to use the hardware, amortir in French, right? Like the term in French. So they have to be able to use the hardware all the way until its end of life, so they can write it off their expenses from a tax perspective. So these kind of these are probably use cases where I would stay on-prem.
Thank you very much. So up to the next question with Aya.
Yeah.
Well, am I going to say again the second question? Well, what I ask is, how can small businesses benefit from implementing the cloud within its solutions? I mean products and services. And which cloud model is the best for such small businesses and startups?
Yeah, so again, the advantage is what I talked about, right? It's basically being able to be up and running using services that you don't have to take care of running yourself, so you can get your business up, right? In terms of the model, I'm not sure what do you mean, like the model in terms of like what PaaS, IaaS, CaaS, or what do you mean exactly by model?
I think architecture, I mean deployment, models of deployment, which be economical ones or technical ones.
I see. I think that it's a very hard question to answer simply because it will depend on what you are doing, but I'm going to try to be generic. I think that generally speaking, if you are a small company, what you want to do is use managed services, right? So instead of, for example, to just put a very simple example, you need a database. You have two options in any cloud provider. You can either run your own database, so take a virtual machine and then deploy a database on it and then run it like that, or you can use a managed database like AWS has something like Aurora and RDS. Google has Spanner and Cloud SQL and Bigtable and all these kind of solutions. We also have MongoDB and Redis managed, where basically we manage the entire stack for you. You don't have to care about it. So you create a Cloud SQL database and you only have like a MySQL endpoint with the default MySQL port, and then you can access that with the MySQL client. But then everything else, the virtual machine itself, the database server, the backups and everything is done for you, right? So this is what we call managed. So this is kind of things you want to do or you want to use. Another would be, but of course there's a cost associated with that, right? Another one would be to use what I call high value services. So high value services are essentially services or products within the cloud environment that give you something super unique that would be very hard, almost impossible for you to build by yourself. So I'm just going to give you an example here. In Google Cloud, we have an API called the DLP API, the Data Loss Prevention API. And what that API allows you to do is basically send a bunch of data to it and it will try to find PII data and then hide it. So it will try to find like social security numbers, email addresses, passwords, license plates numbers. So if you are if you are the DMV, I don't know how to say this. I don't know what's the Moroccan version of that. The DMV, the company that the institution that handles cars, right? Give you license plates, etc. These are the kind of services they want to use the data loss prevention API, because if you want to build it on premise, that means that basically you have to build a machine learning model that is able to read a line or a file and predict whether a specific text is some PII data, whether it's an email, etc. You can do this with regex, by the way. Like somebody would say, like you can do it with regex. No, you can't. It's super hard to do. And so with the DLP API, Google has a bunch of machine learning models. We can detect, I think, something like 45 type of data, right? Like emails, passwords, social security numbers, license plate numbers, etc., etc. And then you just send a bunch of data to the API, and then the return is basically the same piece of data you sent, but we just we replace that PII data with XXX or something like that. So these would be my take on that.
Okay, thank you again. Well, I'm gonna pass my third question. How can we optimize our resources and improve performance using cloud technologies? And is there any instant benefit regarding to return on investment?
I think you already answered to this question, considering the return on investment.
Yeah.
Can we talk about the growing relationship between the two technologies?
Yeah. So the next question, you mean?
Okay, my fourth question is, how would you explain the growing relationship between cloud computing and computing for mobiles? What are the different models for deployment in cloud computing?
Yeah, so there is this new trend, I would say, that is coming up lately, which is like edge computing. We call it sometimes mobile computing. It even have like a mobile MEC, it's called, I think, or something like that. It has like a specific acronym. I think that there is a realization right now that cloud, as it was designed or as it exists today, it's mostly about running your application or running your services on top of a existing infrastructure of somebody else in big, efficient data centers, right? But there are still use cases where you need, for example, to be able to run your services closer to the user for latency. So I'm going to give you a very concrete example here. When you are on an Android phone, right? And when you are on the Play Store, where you download applications, right? You click on, you find an app and you click install. Your phone will have to download a file. It's typically an APK file. It's the package format of Android, right? That file is typically not downloaded from a data center, right? So imagine you are building the Play Store. You are building a Play Store for a mobile. Imagine you invented an operating system for mobile, right? And then you have to provide a Play Store where developers can actually publish applications and then the users can find them and install them, right? If you are trying to make the phone of the user, download that app from a data center, you might run into problems. So if your user imagine, for example, you're using Google Cloud, right? And your application files are on Google Cloud, right? And your phones are reaching Google Cloud to download them. So if you are based in Belgium, for example, or in the Netherlands or in Sweden, it's going to go fast because there is a data center nearby, right? I'm just gonna click download, the application will be downloaded. Internet connectivity in Europe is quite good. But if you are in the middle of nowhere in Morocco, you're gonna have a deep trouble because you have to go all the way to Belgium or all the way to the nearest data center that the cloud provider has to be able to download that application. And so that's the use cases where we start talking about something like a CDN, a content delivery network, which a CDN is another definition of edge or of edge computing, where essentially edge computing, what it means is that you have a bunch of servers that are located at the edge of your network. So it's an extension of your network, but they are physically located closer to the user and they're connected back to the rest of your infrastructure, right? And so in the case of Google Cloud, the Android example I was talking about, when you are actually downloading an APK file on an Android phone, your APK file is not coming from a Google data center. It's coming from a cache location close to you. It's a server somewhere close to you, maybe in Morocco, maybe in Spain, maybe in France, but it's like closer to you so you can actually get the file faster. And these are the kind of use cases where we start talking about things like edge computing. So that the whole concept of edge computing is that you take some computing power and then you just put it closer to the user, so location closer to the user, so that the user latency is slower, but then that piece of computing is still connected back to the main application or to the main infrastructure through VPN or through some sort of connectivity.
Okay, thank you. Thank you very much for this interesting example. Can we do that with the core components of the mobile applications? I mean, components, working components, having a server or CDN close by and
yes,
download data, JSON files, or components.
Yes, you could. The advantage actually of mobile applications tend to be, the advantages today of mobile applications is that you can actually package all the static content in the app, so you don't have to stream it, right? And there is also this, I'm not sure, I'm not a mobile expert, but I have read a couple of articles about this. There is also this new way where your app can update itself without you having to download a new version, right? So the application itself is composed of. Are you still there? Can you hear me?
Yes. Yes.
Okay.
Yes, I'm there.
Because somehow it went into full mode for some reason.
Yeah.
Okay. What I was saying, yeah, like your mobile application has the code itself, right? Like the compiled code, which is, whatever Java code or whatever Kotlin programming language you use. And then there is the dynamic part, and the dynamic part is a bunch of JSON files, as you said, or like images or videos or whatever. And those are just downloaded all the time by the app. So the app is constantly updating itself. So this is a use case where you will want that content to be on a CDN network. So it's faster to download it to the user. I think the best example would be web applications, where, when you load the web application, typically you have a bunch of JavaScript files and you have a bunch of CSS files that get downloaded, and then your page will not render until those files are downloaded by the browser and are available on the client side. And so this is the kind of use cases where people use also content delivery network or CDN or Edge, it's kind of the same thing, to cache those files, and so that the browser can download them faster, essentially.
Okay, thank you. I think this was the set of questions for AI. We're gonna go to see other questions. Questions that will deal with elasticity, scalability, and architecture. And before that, I think we have questions from the live YouTube chat.
Yes.
First question from Shayma. Can you recommend any cloud provider?
Yes, Google. Okay, I'll try to give an unbiased answer here. I think it's really depends, because it really depends what services you are trying to use. I think the best approach is to try all of them, or try at least the big ones, and check what's the added benefits and what the costs. So to give you just a few examples, like when it comes into compute and storage, I think AWS tends to be cheaper than Google. But when it comes into something like Kubernetes or managed Kubernetes, Google Cloud is better than any other cloud provider, because we built that piece of software, so we run it better. So I think it really depends on what you are trying to do, and the best way to do it is to evaluate the big ones, and then evaluate the technical capabilities, what features are available, and then also evaluate the cost, and then choose based on that.
Thank you very much. I know that this was a tricky question, and thank you for your unbiased opinion. I do think that Amazon offers more cheaper solutions, but when you're gonna scale up and need specific applications or specific solutions, I think it's wiser to try and experiment with other providers. I think right now there are other Chinese providers, Alibaba Cloud. It's offering cheaper solutions, and I think it's application-specific solutions, some AI-driven solutions that are very interesting to explore. We're going to head to the next set of questions, with Fatim Zahra. You can go Fatim Zahra.
Hello, sir.
Can you see Fatim Zahra?
For somebody on your side changed the layout, so I can only see myself. But I can hear you. Can you hear me? Hello, can you hear me? Did we got disconnected for some reason?
So here is Fatim Zahra.
Hello, sir.
Can you hear us?
Yes, I can. I said I
Okay.
cannot see you. I think
Okay,
somebody
so-
changed the layout in the app.
Somebody
I can
changed
only
the
see
layout,
myself.
so he can see us. Okay. Okay, so this is Fatim Zahra. Fatim Zahra is also on her fourth year, but
Sure.
she has passion for embedded systems. I mean, especially for racing cars. I mean, she participated in several competitions in racing cars using embedded systems. So she's good with C programming, embedded systems, and hardware-wise in general. So I think she's gonna ask a few questions about hardware or architecture.
Sure.
Hello, sir.
Hi.
So nice to meet you. My name is
Thank
Fatima
you.
Zara.
So maybe she's.
Nice to meet you, Fatim Zahra.
Sir, I want to ask you some questions. My first question is, what is the different layers which define cloud architecture, and what does it take to become a cloud architect?
Yeah, good question. I'll start by answering the second question, which is how to become a cloud architect. There is really no defined way to become a cloud architect. Pretty much everybody can become a cloud architect today. I think that's what people tend to call a cloud architect is somebody who is certified with a certification that says you are a cloud architect. I have one. But I think basically being a cloud architect or holding the job of an architect in general means that you have extensive experience in building stuff, right? So you have worked many years on designing and building solutions. And so you know what works, what doesn't work, you know what to avoid, you know what are the pitfalls, you know all the features available in specific cloud providers, you know all the features available in a specific product that you're going to use, and you kind of know how to stitch things together, so to kind of glue things. It's basically like being a Lego maker. It's like taking several pieces, several products, and just kind of glue them together to make a final solution, right? As I said, there is like no straight path to become, like no single path, I would say, to become a cloud architect. What most people do is that they work they work for a couple of years as a developer or as DevOps or something like that. I certainly had the chance to become or to get certified on cloud architecture. I'm just gonna change the battery of my camera, by the way. So I'll keep talking. I had the chance to become a cloud architect because I worked many years with customers on helping them build stuff, whether that was in Morocco and then later on with Google. So the different layers of cloud architecture are different. Basically, we can always just refer to this like very common way of categorizing cloud services, which is like the IaaS, PaaS, SaaS, and then we can add to it the two, I would say, newer-ish models, which are FaaS, function as a service, and CaaS, container as a service. And so the idea is that in a cloud environment, you have products, and you can, generally speaking, categorize these products into these 5 categories. So infrastructure as a service is the bottom layer. It's the kind of like base layer. So that's where you have things like compute, storage, network, firewalls, load balancers, file servers, stuff like that, right? Like the basic building blocks. Then on top of that, platform as a service is where you have managed solutions. So think about the example I gave earlier, the DLP API is one example. Things like App Engine, things like managed databases, things like managed queue systems like Kafka or managed MongoDB, managed Redis or stuff like that. So infogéré in French, right? Then on top of that, you have SaaS, software as a service, which is essentially this application we're using to have this call, Gmail, maybe a CRM application, maybe an ERP application, maybe anything that is basically a software that you don't have to install on your PC and you can just use it from a web browser. So these are the 3 categories. Now, FaaS and CaaS are kind of newer categorization. So FaaS stands for functions as a service, where essentially you just take a function and you host it somewhere, like literally a function, like as you have studied what a function is in programming languages, you just take that and you put it on a server. FaaS solutions that exist today tend to be kind of lock-in the sense that you have to build your application using a specific programming languages and then using a specific framework. And then you have certain limitations in terms of, for example, when you make a call, how long that function is allowed to run for, like 10 minutes, 20 minutes, something like that. If you make an HTTP call to your function, how long is the session is allowed to be open for before it's killed and stuff like that. Then you have this new category coming up to the market now called CaaS, containers as a service, where essentially you take a container and then you send it to the cloud provider platform, and then the cloud provider will just run that container for you, scale it up, scale it down. So examples in Google Cloud are something like Cloud Run, where you just literally write a container using a Docker file or something, and then you just take that and you send the code to us, and then we will build it. So we take the Docker file, we'll build the container, we will host it, we will give you a URL so you can access your container. So if it's a web application, you can just click on the URL, you get the web application, it's HTTPS, so we do all the HTTPS management for you, all the certificate management. You can map it to a custom domain, and you get auto scaling, so it scales up and down, etc. AWS have just released something lately called the AWS App Runner, but there are other examples like Fargate, which is an AWS product. Google has GKE, which is the Google Container Engine, Kubernetes Engine, sorry, and stuff like that. So these are kind of the categories, I would say.
Thank you, sir. So my second question is, what is the difference between elasticity and scalability in cloud computing?
Yeah, very simple. Scalability is essentially being able to scale up and down as you need. It's essentially being able to go from 1 instance to 20 instances like that. That's what scalability means. And typically scalability means that you are also able to do it automatically in an environment. Most cloud providers have this auto scaling, which is a way to scale up and down in an automatic way, so you don't have to do it manually, right? A typical example would be that you have a set of instances behind the load balancer, and then you use the load balancer signals as a way to scale up and down. So the load balancer, for example, could count the number of requests, and as the number of requests is increasing, it will just add more instances. So that's what we call typically horizontal scalability. Horizontal scalability means you just add more instances. You have also something called vertical scalability, where essentially you have an instance of a certain size, and then you need to scale up. So you just scale it and replace it with an instance of a bigger size, right? So some cloud providers have this as well. Elasticity is essentially being able to access the resources when you need them, right? So I'm hitting echo. So you need a bunch of resources, you need a bunch of servers, you need a bunch of computing power. You'll be able to just access it whenever you need. That's essentially what elasticity means.
And my last question is, what is the system integrator in cloud computing, and how does pay as you go or backward?
Yes. So a system integrator is typically a company that has a piece of software that they host on a cloud provider and offer it to the customers, right? So taking the example here would be something like SAP. It's a pretty popular piece of software. I know that in Morocco we use it quite heavily. It's an ERP, enterprise resource planning software. And you could actually buy SAP in different formats. You can either buy it from the company and just use it as is, so you install it yourself, or you could just buy it as a SaaS, software as a service, where essentially they will install it for you on a cloud provider and they will manage everything for you and you just have access to it through like a web browser or client. There is also, sometimes we call system integrators as basically consulting companies, like companies that are specialized in consulting and that have people who have expertise in certain cloud providers and that could help you actually put your application on cloud providers. This is essentially what I do, but we are doing it with Google. So we only work with few customers, but there are like this huge number of companies out there. Some that you might know are things like Capgemini, Atos, Accenture, Tata Consulting, and a bunch of other companies like that. When it comes into the pay-as-you-go model, it's the example I gave earlier about paying only for the minutes you use a virtual machine for. How it works depends on the platform. So for things like compute, it tends to be per time you use the service for. So you spin up a VM for 10 minutes, you pay for 10 minutes. For storage, it tends to be for the gigabytes you're using, 10 gigabytes, 20 gigabytes and stuff like that. For APIs, typically you pay for the requests. You have an API and then something like, you pay $1 for every 10,000 requests or something like that. So that's kind of how, so the pay-as-you-go model, the idea is that you only pay for what you use, right? If you're not using the service, you don't pay for it. And I think that these are the three categories probably. Pay per compute, pay per storage, or pay per request.
Thank you, sir.
No worries.
Thank you. Can you hear us up there?
Yes, I can.
Okay, so I think this is the second set of questions by Fatim Zahra. And as I said, those questions were more about architecture and the cost benefits of using such said architectures. Before heading to the last set of questions, I think I have a question from the YouTube chat.
Yes.
Security risks in cloud computing. And I think you already handled that question about the security aspects in cloud computing. Okay, we're going to talk about career guidance, and the last set of questions will be by Umayma. You can go, Umayma. Okay. So in this last set of questions, Umayma will be asking you about thank you.
Yes.
About certifications, I guess, and I mean the title of the event is more about how to jumpstart your cloud career, and we ended up talking about solutions, architecture, benefits, cost benefits, and so on. I mean, this last set, I hope this last set of questions will tackle that career guidance part. Yeah. Okay, here's Umayma.
Hello, sir.
Hello, how are you doing?
Yeah, I can hear you.
Hello, sir. Can you hear me?
Yes, I can. Can you hear me?
Yes.
So I'll start with my questions. My first question is, what are the cloud certifications that you would suggest for a non-graduate junior student that are affordable? And is there any advanced one that you would highly recommend?
Sure. I think Ahmed put this question because he knows my opinion about this topic, and I have a very strong opinion about it. I believe that, okay, let me try to make it super clear what my answer would be. I believe that for non-grad students, aiming to be certified and thinking that if you are certified, you will find a job easily is the wrong thing to think, right? I'll tell you why. A certification is typically a proof of experience. It's not a proof of knowledge. And then I just want to make a clear difference between these two things. A proof of knowledge is a piece of paper that says that you know something, right? That you have read about it, you have been tested, you got an exam, and we have checked that you know that topic, right? That's typically what a degree is. That's what you are doing right now at university. You're getting a piece of paper, which is a diploma, that says that you know a certain set of topics, right? A proof of experience is a proof that you have hands-on experience on that topic, right? I'm hearing myself again. All right. So certifications, what they are is that they are typically a proof of experience. They are a proof that we have assessed that you have experience on a certain topic, right? That's what certifications are. For a grad student, the problem is that if you are still at university, you don't have a way to have hands-on experience on something, right? When I mean hands-on experience, I don't mean that you have done a specific topic for 30 hours taught to you by a teacher. That's not a proof of experience, because what you would experience at university is mostly high-level stuff, basic knowledge plus high-level stuff, right? But professional experience means that you know that topic in and out very well. And that's what certifications are about, right? So to me, being certified, if you're not a cloud grad student, if you want to do it just because you want to learn about the topic, it's fine. If you do it because you think it's going to help you get a career or get a job, and then when you get certified, you put that like front and center on your resume, and then you make your resume about the fact that you're certified, I think that that's the wrong thing to do. Because basically, from the eyes of a recruiter, it's going to be like, we have this person who just graduated from university, but they have AWS certifications or GCP certification. That doesn't mean that they know AWS or they know GCP, right? So this is the answering the question of like, giving my opinion about it. Now, what the exception to all I said would be a single case where what certifications are good at is that they give you a way to have structured learning, because the whole point of a certification is that in their curriculum, it's like going step by step from simple concepts into complicated concepts, right? Like advanced concepts if you want. And so this is a good thing for people who have a struggle learning. There are people who cannot actually learn if they don't have a structure, if they don't know exactly what they should be learning at what moments. And certifications are great for that, right? Now, for grad students, I mean, there are a bunch of good ones that I would recommend anyway, just to know the topic, not necessarily to prove that you know it, but just for you to know it. So the Linux Foundation has a bunch of good certifications for Linux. The Linux Foundation Certified System Administrator is a good one. It's a really good one for you to know that for you to learn Linux, essentially. I wouldn't recommend to go to any type of certification which is specific. So anything around Kubernetes, I wouldn't recommend that, because I think like Kubernetes is so complex that you need to spend a couple of years working on it before you get certified in the first place. Anything that is like technology specific, like there is like HashiCorp, the company has a bunch of certifications for their products like Terraform, Vault, Console, stuff like that. I wouldn't recommend any of that. Cloud certifications, most cloud providers have these like entry-level certifications. They call them typically associates. In Google, we call it Google Cloud Associate Certification. I think AWS has the same. That's something I would recommend for people to kind of get an idea about what AWS and what Google is. I would not recommend people at university to start going to an architect certification, because it doesn't make any sense. And it will be very hard for people actually to pass it anyway in the first place.
Thank you. I do agree with your point of view. You said you have a strong opinion about the subjects. I mean, there are a bunch of professors around here with us today, and we all agree with you. It's not about the certification. It's not about the paperwork. It's not about I have a proof that I finished a curriculum or something like that. Yeah. It's more about what you can do. What is your value if you end up working in a team. I mean, what you can do. Do you have any proven knowledge? I mean, proven by projects, by contributions, by something like that. So yes. I personally recommend young undergraduates and graduate students to start working on projects. I mean, there are a bunch of open source projects that they can contribute to, or they can work in groups in order to create something. In their education, they can find lots of projects in where they can contribute to have some proof that they can handle the task. Yeah. So we're going to talk about the next question, because you said while recruiting someone, what we look for is the skills, the necessary skills. So if you're recruiting a cloud engineer or a DevOps engineer, I mean, what basic skills you're looking for, and what would make this candidate, I mean, the skills and requirements that will make this candidate stand out from the rest. I mean, if you put yourself in the place of a recruiter.
Yeah, and I do actually recruit. We at Google, we have interviews are done by Googlers. So we interview the people who are coming into our team. It's not like managers interviewing people. If you want to join Google, by the way, just FYI, you're gonna pass anywhere between 6 to 8 interviews, and out of all these interviews, it's gonna be one manager interview. Everything else is going to be peers, people like you, people who are already in the role, right? People who are already in the role and who are trained on conducting interviews. So for cloud engineers or like DevOps or anybody who's going to work in the cloud, the technical skills I would be looking for would be fundamentals. Do you understand web? Do you understand databases? Do you understand distributed systems? Do you understand operating systems? Do you understand programming? So the fundamentals, the basic things, the basic building blocks of any computer science grad or undergrad or somebody with experience. I had the chance to conduct some interviews for newly graduated people for a company that I work with in Morocco. And a very simple example, a very simple question I was always asking is, can you explain internet to me? This is something that you will be shocked by how many people cannot explain internet, and they claim that they are engineers. So just explain internet from the basic. Explain what happens when you type www.google.com in your browser all the way down to when you get the page back, right? Just explain that. That basically involves a lot of things. It involves your understanding of web, your understanding of HTTP protocols, your understanding of DNS, your understanding of network, your understanding of servers, your understanding of the whole internet, essentially. And we can go beyond that into things like your understanding of routing, your understanding of how networks are connected together, etc., etc. So this would be the technical stuff, right? The fundamental building blocks of anything. Now, if I am hiring for a specialized role, somebody with specific experience, then we might explore things like your knowledge about specific technology. Like if you're hiring a programmer, you want to know that the person knows algorithms very well. They can write a piece of software. They can explain what that piece of software does. They can explain the complexity of that piece of software. They can explain things like the resource utilization, etc., how to optimize it, etc. So these are a couple of things. The other skills, which we usually call soft skills, are things like how do you conduct yourself in the interview? How do you explain? How do you argument? How do you understand the question? Break it down into small pieces, and then answer it in a structured way without jumping between stuff, right? Between topics. How do you problem solving is another one. So like, how do you solve a problem? There are a bunch of interview questions which are known that you can ask people, and they can like put them in a situation and then ask them, so how would you solve this, right? So these are the kind of skills. So problem solving, argumenting, talking, speaking, conducting yourself in front of a group. I think that's a key skill that people should have, is the way you communicate. Because when you join a team or you join a company and you join a group of people, you are expected to basically deliver the work as a team and not as an individual. Computer science is not an individualistic task. It's not an individualistic field. This is not like you're a doctor just fixing a patient by yourself. Computer science is more like a surgery, where you have many people gathered around the patient and trying to fix whatever is wrong with that patient. But everybody has a role they play. There is an anesthesiologist, there is like a surgeon, there are nurses, there is like a bunch of people like that. So how do you work in a team? How do you conduct yourself and collaborate is actually also a very important skill. And that's essentially what projects at universities are supposed to be able to teach people. What ends up happening most of the time is that there is a group of 4 people. One person does all the work, the second person prepares the presentation, and the 2 others doesn't do anything. But that's kind of the skills you're actually trying to look at when you interview people.
Okay, thank you very much for this valuable set of answers, because you went through the things, the building blocks that make candidates stand out. you pinpointed mainly problem solving and how you communicate with your peers, how you tackle the main idea or the main problematic, and how you communicate and try to solve in a group. Because as we know, human beings are social individuals, and you can't work, on your own. You have to communicate with your peers and try to solve the problem together. I think, considering this skills development aspects, I think Umayma has a question about learning.
Yep.
What is the question, Umayma?
Okay, so in learning about the subjects, we should focus on the building blocks of cloud architecture, or take a specific provider and try to master its specific product range. In this case, what SP would you recommend, or what product?
So is it like to follow the market and try to master a specific technology, or focus on building blocks and theoretical aspects of cloud computing?
I would say that you should focus probably 70 to 80% of your time on building blocks. So you know what an if you know what an operating system is, and you know how a virtual machine works, you would know how a virtual machine works in any cloud provider, essentially, because they are pretty much all done the same way. Fundamentally, computing in general did not get any major changes since machine learning, right? Like before machine learning and after machine learning, we're still using the same thing. We're still using compute, storage, network. There are few variations in these things. There is like much faster network cards. There is probably some new protocols that showed up in the last few years, like QUIC and HTTP2. These are the kind of gRPC, for example, there is kind of things you want to learn. But let's take a concrete example. If you are trying to build an API, right, what you want to do is understand what HTTP REST APIs are, right? How do they work? Probably alternatively what gRPC is, which is a different way of doing APIs, and how do they work? What HTTP and HTTP2 are, HTTP1 and HTTP2 are, and what's the difference between these two things. You need to understand these things. You need to understand the concept of a backend, what is a backend, how it works. You need to understand the concept of an API spec. So how do you define an API specification? How do you map that specification into actual code that does something? And then picking a cloud provider is like, I think that if you want to pick a technology that you want to learn with a cloud provider, go for the complex stuff. Like the basic stuff, like I explained, storage and virtual machines and stuff, is basically the same thing everywhere, right? There are variations probably that, when you create a virtual machine in a Google Cloud, it comes with a public IP, but it doesn't come with public IP in AWS or something like that. But it's like small variations, right? So these are the things. Then the other part of the question was like what I recommend as products and as cloud providers. Again, for a non-grad student, I would still recommend to just focus quite a lot on building blocks. Probably look into something like, so here is my problem, or here's the point I was trying to make. If you want to learn about, if you are a student, right, and you want to learn about a specific technology, let's take Kubernetes as an example, right? You need to understand what Kubernetes solves as a problem, right? So if you don't expose yourself to a situation where you understand what that technology solves, you're not going to understand what the technology does. I got into Kubernetes 3 years ago because I have 15 years of experience working with non-containerized, non-Kubernetes based platforms. So I saw the problems there. I saw all the pain that we had to go through to be able to get into what Kubernetes does today, right? Or something like service mesh as well. So I've done a couple of other projects where we didn't have a service mesh, and then it was like painful. So I think that if you want to necessarily pick something, probably pick a cloud provider and pick some labs. All the cloud providers have some form of labs where you can just go through them and just see like, okay, so how do you create a database? How do you do this? How do you create a web server and stuff like that? And just like kind of have a look at those, but don't focus too much and don't try to be expert. Like you will get expert when you get a job and you get like an experience. I myself still today just go back to the basic building blocks whenever I'm learning something, because maybe the few technologies I would recommend people to look at are containerization today. It's like kind of becoming the de facto for pretty much all the apps. So learning how containers work and what they solve. Learning maybe something like backends and frontends and how like what is backend, what is frontend, how do they actually interact with each other. Learning how APIs work, and then picking an API product. It doesn't matter which one. Yeah, this would be my take into it. I don't know if I answered the question.
Yes, thank you very much. You surely did. So it's more about the journey. I mean, you start step by step in order to try to achieve a certain goal. So you need to fix your goal into the learning journey and start step by step working your way up to that goal.
Yes. I cannot hear you anymore. Are you talking?
Students or young professionals that are listening to us about how to jumpstart their cloud career.
Can you repeat the question? I didn't hear it, Shema.
Okay. Yeah.
Okay, is there anything you would like to say to CS students or young professionals that are listening to us about how to jumpstart their cloud career?
Yes. So first of all, focus on the fundamentals, as we talked about many times. Focus on all the basic fundamentals, right? So the fundamentals are, again, operating systems, distributed systems, databases, web technologies, you know, a little bit of networking and stuff like that. So this would be my one thing. The second thing would be, I mean, I don't think that anybody today should ignore Kubernetes, Linux. So learn Linux very well, know how to navigate your way around it. The best way to learn Linux is not to use Windows, as I say all the time. So just get rid of Windows and install Linux, and then enjoy the pain of using Linux until you can master how it works. By the way, Mac doesn't qualify. So Mac does not qualify as Linux. Mac is an easy Linux, and that's not, if you have a MacBook, you're not on Linux, you have a MacBook, it's a different thing. Then what I would say is get your chance to do some public speaking. There are a lot of great communities right now happening on the internet. One of them is the Geeks Blah Blah. People might know it. Geeks Blah Blah is a community of people that are centered around tech, and they do a lot of events. Maybe join the Facebook page, maybe try to participate, try to answer questions on the Facebook page, try to basically propose to talk about the topic, like do a conference about the topic. Or join our community. We have it, the Cloud Native Compute Foundation community. You can find it in Facebook, CNCG_Casablanca. It's the Cloud Native Compute group, and it's a community of people centered around cloud native technologies. And listen to my podcast. I have a podcast about cloud careers, which Ahmed talked about earlier. So it's cloudcareers.dev. So cloudcareers, plural.dev. I have already uploaded 4 episodes, and I am going to be uploading more episodes in the future.
Okay, thank you very much, Abdel, for this long and entertaining conversation. It was a meaningful conversation, surely deepful, because you tried to answer a list of questions ranging from technical suggestions. You shared your opinions about some architecture, some models, and also technologies and products. You also shared with us your passion about cloud computing and cloud solutions in general. I mean, for our audience, I would like to thank you for reaching this far, because it was a quite long discussion. And I would suggest, if you have questions about the economic and implementation aspects of cloud computing, because that's an aspect that needs further discussion, you can reach out to Abdel on social media about tech advising and stuff like that. For our students, I hope this was quite learning experience, and that it gave you enough passion and motivation to start your own journey in cloud careers. I guess I'll be seeing you Saturday, Abdel.
Yes. No, I will not be present. I cannot make it to that, but there will be Karim, my co-host, and Mohammed.
Okay, thank you very much, and see you next time. I mean, okay, bye.
Thank you, folks.
Thank you.
Have a good one. Bye.